All right, good afternoon. This video is kind of a initial walkthrough for the week 4 virtual lab, which is called It's All Elemental. So a couple of things I want to point out to you about this. The reason why you are in Zoom right now is you are supposed to be working together with your other virtual classmates here to solve this problem. This is designed as being a project in two parts. One part working together as a group, a second part working individually as kind of a reflection exercise. So if we go to the procedure itself here, in the procedure, you will see that you are being presented with a scenario. The scenario is this. You work for an international organization that is doing collaborative work. You have received some transmissions from another planet that contain individual information about the elements that are on that planet. Now, you being a chemist, or at least this case, a chemistry student, you know that all elements are the same regardless of where they are. It's just a matter of kind of decoding their system to match our system. So what you are going to be doing is you're going to be taking these transmissions with these individual element descriptions and working together to develop a arrangement of sorts of those elements into a periodic table. So eventually what you will get to is you will match those cards up one to one to one with the elements that are on our periodic table. So if you go into Blackboard, you will see that in Blackboard, there are a bunch of things here. First of all, there is a procedure page. That's what I was just pulling up. This tells you what you need to do, when you need to do it, what the general rules are for how this table is constructed. And so things that you should know. None of the transmissions are for for transition metals. All of them are for objects that are in what we would call the main group. So that would be the first two groups of the periodic table and the last six groups of the periodic table. You'll be working together in groups, starting in kind of small groups. So I'll probably break your group. I will break you into halves, probably two groups of three. Initially, have you work in your triads to try to figure things out. And then by the end, I'll get everybody together so that you can all kind of work through the one and make one table by the end. So here in Blackboard, you'll see that you've got a document here with your periodic table, the cards, the transmissions that have been sent, and those I have kind of re-engineered. So what I would do honestly here is these are movable pieces, so you can just click and drag and move them around as you see fit. What I would have you do is in your groups of three, have somebody pull this up, share the screen, and then everybody interact with it and start to try to piece together the table itself here. So use all of the information. So there is chemical information here in terms of, what is it? Is it a metal or a non-metal or a metalloid? What kinds of oxides does it form? And then there are overall trends here, quantitative trends that are based on physical properties, sizes, densities, atomic masses, and so on. Now remember, each one of these elements does have a corresponding element on our periodic table. At some point, you will have to line them up with each other, but that is not something that has to happen right away. You might want to just think about, okay, what groups do they fit in? How do they kind of work? A couple of things to also consider. The atomic size, atomic mass trends, those do match up with the trends that are in our periodic table. So you might want to have chapter 3 of your textbook open and look at how those trends for mass, size, how does our periodic table arrange them? Because those are going to match up quite nicely as well. So once you get to a point where you've got these arranged pretty nicely, you're going to give me a heads up. Once both groups have kind of completed things individually, I'm going to put everybody together. You're going to continue to do the same task and come to consensus as a group of 6. And once you have a group of 6 consensus, then you will open up this last document where we have 4 other cards, 4 other elements to slot in. If you've done the work correctly leading up to this point, should not be too terribly difficult to just kind of slide those around and get them to fit into the holes that are left behind in your periodic table. Once you've got all of those in, that's a total of 20 elements in this particular periodic table. You will submit to this area right here, the group table submission. This is the place where you will submit your overall group table. And you only need to make one submission for the 6 of you. All 6 of you will be graded the same way because you'll be using the same table. And that is what is described here as your group model. And so your grading on that is going to be very simple. Does the table contain all 20 elements? That's half of the 10 points. And the other half is, have you done it correctly? Do they align in families correctly? Are the periodic trends what we would expect? And that's 10 points. The other 5 points comes from a reflection paper that you're going to write individually. So all 6 of you are going to have to write the paper on your own, submit individually into Blackboard. This can be a Word document or a Sheets document, some kind of online word processor of some sort. And just write some really simple, what did you do? What was your task? How did you go about solving the problem? What kinds of things did you talk about in your groups? How, when you got merged together, how did things change? Did anything have to be adapted when you added new elements to the table? And then finally, compare. How does your table compare to the modern periodic table? How is your process the same or different? How do things look for you versus how did they look for Mendeleev and for Lothar Meyer and others? So in total, your total reflection paper should be a couple of paragraphs, certainly not more than a page at 1.5 spacing, normal font size. But that's it for this particular experiment. There is no quiz for it. The only things that you need to turn in, you'll need to turn in the group model by the end of the lab today. You'll need to turn in the individual reflection paper by our due date that next Monday. No quiz. And I'll be checking in on you in Zoom to make sure that you're kind of making progress and going through things, thinking about them in the correct manners. So that's all for this pre-lab video. Right now, if you go into Zoom, you'll see that you have been split into 2 groups, and I'll invite you to go to those 2 groups and start working on the problem, and then I'll combine you at a later time. But go ahead and get started.